In this video, we are going to conquer molar conversions. These will be one-step conversion problems. Make sure you have a periodic table and a calculator, and it needs to be a scientific calculator because we're going to be using scientific notation numbers. Before we begin doing some conversions, I want to make sure we understand some relationships. So one relationship we need to make sure we understand is that 1 mole of anything equals the molar mass of that substance. And that is in grams. We also know that 1 mole of anything equals 6.02 times 10 to the 23rd particles. Now particles can be atoms if we're talking about elements. It can be molecules if we're talking about covalent compounds, or it can be formula units if we're talking about ionic compounds. All right, let's look at this problem. How many grams are in 6.2 moles of aluminum? So when you're given a problem, look at what they gave you and then see where you're going to. So they gave us 6.2 moles. So we're starting in moles. And they want to know how many grams. So we're going from moles to grams. All right, so now that we know that, we can set our T-chart up and be able to see where to put all of our numbers. Okay, so we get a T-chart set up, and this is going to help us organize our numbers. So you take what they've given you. They've given us 6.2 moles, and we're going to put that in the upper left-hand corner. And you let your units tell you what to do. So we have moles in this left corner right here. We're going to take moles and put it down here in the lower right corner. That way, these two units will cancel out. Now, this is a one-step conversion problem, so I know I can go right from moles to grams, which is what they're asking me. So what numbers do I put here? Well, we know a relationship, 1 mole equals the molar mass, which is in grams, and that's what we need because they said how many grams. So where do we get this molar mass? Well, we know the 1 goes with the mole, so we're going to go ahead and put that there. But then we need to find out the molar mass. Well, the molar mass of who? The molar mass of aluminum. So if we pull up our periodic table and we look for the molar mass of aluminum, you will see that it's 26.98. So we pull that from our periodic table, put that back, and then we're going to write 26.98 right there. So we have our problem set up. At this point, we need to get your calculator. So you get your calculator and you're going to put 6.2 times 26.98. And your calculator will give you 167.276. All right, well, this is way too many units. So we need to look at the number we started with, which is 6.2. That tells us we can have 2 significant figures. So we need to take this number and only have 2 significant figures. So that would mean we're going to have to say 170 grams. And it's always good to box or circle your answer so you can see what the answer is, because we've done a lot of work, and so we need to kind of highlight what is our answer. So go back to the question that they asked us. How many grams are in 6.2 moles of aluminum? So to answer this question, you would say there are 170 grams in 6.2 moles of aluminum. Let's look at our next problem. Convert 5.4 times 10 to the 25th molecules of carbon dioxide to moles. So let's look at what we're given and where we are going. So they've given us molecules and they want us to go to moles. And once again, this is a one-step conversion. So I'm going to draw the t-chart, and I know I'm going to just need one step. So you take what they've given you, and we're going to put that in the upper left-hand corner of our t-chart. So we have 5.4 times 10 to the 25th, and we're going to put molecules. Now the particles here are molecules because carbon dioxide is a covalent compound. So once again, let the units tell you how to set up our conversion factor. We have molecules there, and we're going to bring that unit down into the lower right-hand corner. So that kind of lets us set up this relationship that we have. Well, what relationship are we talking about? The relationship that we wrote down right at the beginning of this video. 1 mole equals 6.02 times 10 to the 23rd, and it said particles. Now in this situation, the particles is molecules. So when we look at this relationship and we look, well, where do we put these numbers? Well, molecules is here, so that is where we're going to put 6.02 times 10 to the 23rd. And on top is where we put the 1 mole. So you can see that our molecules can now cancel out. The molecule unit cancels out, and we end up in moles. And that's what the problem asks. Convert molecules to moles. All right, so in this situation, you need your calculator. Now you need a scientific calculator because we have the exponents. So you can take 5.4 times 10 to the 25th, multiply that by 1, which is the same thing, and divide it by 6.02 times 10 to the 23rd. And your calculator will give you a nice long number, and I'm not going to write all those numbers down. I'll just write a few down because we have to look at our significant figures. So we have 89.7009 and so forth. All right, so when I look at my number in my problem that I started with, it is telling me I can only have 2 significant figures. So I need to round this number to only 2 significant figures. So my answer is going to be 90 moles. So when you go back and you look at what they asked you, convert 5.4 times 10 to the 25th molecules of carbon dioxide to moles. So 5.4 times 10 to the 25th molecules equals 90 moles. All right, another problem. How many formula units are there in 0.76 moles of sodium acetate? So let's look at the problem. What are they asking for, and what did they give us? Well, they gave us moles. They gave us 0.76 moles, and they said how many formula units. So we're going to be going from moles to formula units. And remember, these are all one-step problems. All right, so let's make our t-chart and get started. So we make our t-chart, and we're going to start with what they gave us. So we're going to put 0.76 moles up in this upper left-hand corner. And this unit that we just wrote is what we put down in the lower corner. And then where are we going? Well, we're going to formula units, so we can put that in the upper right-hand corner. And now we just need to get the numbers. So if you look at the relationships that we wrote at the beginning, we know that 1 mole equals 6.02 times 10 to the 23rd particles. All right, so this is where we get our number. The 1 is next to moles, so we put the 1 there. 6.02 times 10 to the 23rd is going to go right here. 6.02 times 10 to the 23rd. Okay, so we have 0.76, and you multiply that by 6.02 times 10 to the 23rd. And you will get a long answer in your calculator. Mine has 4.5752 times 10 to the 23rd. All right, I need to look back at the number I started with, this 0.76. I have two significant figures, so I can only keep two significant figures. So my answer is going to be 4.6 times 10 to the 23rd, and see what unit we're in. The moles canceled out, and we are ending up in formula units. So you want to box or circle your answer so it's clear what your answer is, and then go back to what the question asked. How many formula units are there in 0.76 moles of sodium acetate? There are 4.6 times 10 to the 23rd formula units. Now, does that make sense? Well, it does, because in 1 mole, there's 6.02 times 10 to the 23rd. 0.76 is less than 1 mole. So this number here should be less than that number, and it is. All right, I hope that you feel more confident in conquering molar conversions. I will have more videos with more problems, more one-step problems, and then a little more difficult two-step problems. So keep watching these videos, and together we can conquer chemistry.